In today's class, we'll see for standard form 3. I think the second one was only the variable and separable. We were separating the terms. Variable and the separable. Your standard form 3. That is variable and separable. Here you are going to have your form, the terms of F1. Equation of the form will be equations of the form F1 of x comma p it's equals to F2 of y comma q. That is equations not involving z terms, only containing x and y terms and p and q terms. That means in the third rule we are not going to have any z terms. Equations not involving z and the terms containing x with p and y with q. You have to separate the terms and you are going to do the integration on this one. Here you are going to use your total derivative you are going to use. What you are going to do, you are going to substitute f1 of x comma p it's equals to a and your f2 of y comma it should be y comma q it's equals to a you are going to take and you are going to solve. From here you are going to find your p value. Solving for p and q, you are going to get your p is equals to capital F of x comma a and your q is going to be f2 of y comma a. Since your z is the function of x and y, so we can write the total derivative. Since z is a function of x and y, so we can write dz is equals to dou z by dou x into dx plus dou z by dou y into dy. Since we know that dou z by dou x stands for p, this value stands for p and this value stands for q. Therefore, that is going to be dz is equals to p into dx plus q into dy. Now you are going to integrate on both the sides. You are going to integrating on both the sides. Integrating dz it's equals to integrating p into dx plus integrating q into dy plus some arbitrary constant c, where your p value, what you got, your p is equals to f1 of x comma a and q is equals to f2 of y2 comma k. That values you have to substitute. Your z integration of constant is equals to with respect to what you are doing, that variable it will come. Z is equals to integrating f1 of x comma a then plus integrating f2 of y comma a into dy plus c. When you are going to solve this integration, That integration is going to be the required integration for variable and separable. Is it clear, Aditya? How you are going to identify for the third one? You are not going to have any
Yes.
z terms.
Yes.
It's going to be in the form of f of x comma p is equals to f2 of y comma q. From here you're going to separate your p and q, where you're going to take x terms along with the p and y terms along with the q. Then after that, since we know that z is a function of x and y, so the total differentiation we can write dz is equals to dou z by into dou z by dou x into dx plus dou z by dou y into dy, where we know that dou z by dou x stands for the notation it's a p, and dou z by dou y stands for the notation q. Then after that you're going to substitute the values of p and q, then you're going to do the integration on both the sides. That will give you the required solution. Is it clear?